Okay, so previously we see two things. Number one, circular turn with friction, and the second one is banking of road. Okay. Now, and with this banking of road, we see one numerical also. So first of all, let's start with some numerical, one or two, then we move on to the next part. See the first question. These are two lovely question is there related to the circular turn with friction. A cyclist speeding at 18 kilometers per hour. So what is the speed? 18 kilometer per hour. That is 18 into 5 by 18. That is 5 meter per second. So a cycle moving with a speed of 5 meter per second or 18 kilometer per second on a level road takes a sharp turn of radius 3 meter. Okay, without reducing the speed. माने cyclist जो है circular turn लिया without reducing the speed. Okay, and without bending towards the center. माने अगर तुमने bending किया तो bending of cyclist हो गया. So then the cyclist get the extra advantage. लेकिन यहाँ पे बोल रहा है cycle ने bend नहीं किया है. So he don't get any extra advantage. Okay, which we discuss later on कि extra advantage क्या मिल सकता था. ठीक है. Without bending towards the center of the circular part, the coefficient of friction between the tire and the road is 0.1. Will the cyclist slip while taking the turn? क्या cyclist slip कर जाएगा जब वो circular turn लेगा? तो मैंने पहले भी बताया था कि if you have a circular turn, okay, so frictional force, that is mu mg, must be greater than equals to mv square by r. So I can easily cancel m. So v square, here it is not the minimum, it is the maximum speed. Maximum speed you can affordable in this situation, that is root under mu rg. See, I already show it to you for the first case. I already show it in the first case. This one, root under mu rg. So you get the root under mu rg. Now everything is given here. Mu is given 0.1, radius of the track is 3 meter, and the gravity is 10 if we use. So then the speed is coming 1.72 meter per second. This is your maximum speed. And you can afford maximum this speed. And what is your real speed? 5 meter per second. So obviously, yes, you slip. Yes or no?
Yes, sir.
So the cyclist will slip. Yes, slip off. मतलब फोटो लग सकता है. Yes or no?
Yes.
Okay. Now the second question is similar question. One more question is there. Similar type of one more question is there. So I want to discuss this also, and then we move on to the next part. Okay. The question is that a bend in a level road has a radius of 100 meters. So what is the radius? Radius is 100 meters. Find the maximum speed while a car turning this bend may have without skidding if the coefficient of friction between the tire and the road is very high, given 0.8. ठीक है, तो बोल रहा है कि maximum bending speed कितना हो सकता है. So the same type of question I can use. So what we can write? We can write V max equals to root under mu rg. Mu is given 0.8, g is given 100 and 10. So what you have, 80 into 10, that is 800, that is 2 root 2 into 10, which is nearly equals to 28 meter per second. 28 meter per second काफी ज्यादा है, because here the friction is very large, coefficient of friction, and radius is also very large radius. So now we can see the rest part. We can see the next part, next level. The heading is bending banking of road with friction. Banking of road with friction. So in this banking of road with friction, you have two situations. So first one skids up or maximum velocity. See, I want to show it you what exactly happening here. What exactly happening here? Okay, suppose this is my back bending of road, and here a vehicle. So skids up means you are taking the turn with a very high speed, maximum speed. So if your speed is more than maximum, your tendency of motion is you are skidding upward. Yes or no? ऐसे करके जो तुम टर्न ले रहे हो ऐसे चले जाओगे. So if you are skidding upward, in which direction friction apply? Friction apply downward. Yes or no? If this is your bending of road, you are skidding upward. So friction apply downward. Yes or no? Yes, sir. So I want to show you that part. So this one is my bending of road. Theta is the angle of banking. Okay, we know this h is the height, this is the width, we know all these things. Now the center is in this side, so I'm putting a block here, or I'm putting a block means car, bicycle, cycle, whatever. Okay, now the most important part is that mg is acting downward, normal reaction is acting upward. Normal reaction is divided in two parts. One is this one, this angle is theta. That also I already discussed with you. See, yes, already I discussed. Yes, that is, that part is r cos theta along the base, and perpendicular with the base is r sin theta. Now see what happened. Now see what happened. Key frictional force acting downward. As its tendency moving upward. So this angle is theta. So this one is mu r cos theta. This one is mu r sin theta. So what we can write? We can write the first equation, total upward force. How much force acting upward? R cos theta, equals to total downward force. Equals to mg plus mu r sin theta. So r is what? R is cos theta minus mu sin theta is equals to mg. Let it be the equation number 1. Similarly, if you see towards the center, how many force apply? 2 force, this one and this one. As 2 force apply, that means net towards the center. If towards the center force increase, that means velocity increase. So that's why this is the maximum speed. Okay, that's why this is the maximum velocity or speed. So what we can write? We can write r sin theta plus mu r cos theta towards the center, nb square by r. R is the radius of the track. I think all of you know radius of the track is inner radius plus outer radius by 2. So if we take r common, what we have, sine theta plus mu cos theta equals to mv square by r. So now from this equation 1 and 2, from this equation 1 and 2, dividing equation 2 by equation 1, dividing equation 2 by 1, what we have are sine theta plus mu cos theta by r cos theta minus mu sine theta equals to mv. You can write max. Why v max? Because that is the maximum. But in your school book, or you can say SL Arora, your 11 board textbook, it is not written maximum. They just write v. Okay, and they only show you that skids up condition, but they don't show you the slips down condition. But if you see the HC Burma, they show you both skids up and slips down. So we show it both, depend on the exam question. If they just say, so you just do that one. If they say he skids up and slides down, so you show both. Okay, so v max, mv square max r by mg. So what we have, v max square by rg. I can cancel this rr. So so overall what happened, now I can divide it by cos theta. Before that, v max square, that is rg sine theta plus mu cos theta by cos theta minus mu sine theta. So v max is root under rg sine theta plus mu cos theta by cos theta minus mu sine theta. Now I can divide this with cos theta both sides. I can divide this by cos theta, by this also cos theta. So what we have, rg sine by cos is tan theta plus mu by 1 minus mu tan theta. That is my v maximum. Okay, everyone?
Yes.
Yes. So this is the condition when it skids up. Now the second condition is, second condition is condition 2, slips down. Second condition, slips down, or you can say minimum speed. Minimum speed. Velocity लिखना ठीक नहीं होगा, because it's not only the direction, because every time you change the direction. That's why I'm just taking the magnitude. Okay, so slips down on minimum speed. So same way we can try. Only the difference is everything is same. This is my inclined plane. This is the angle of inclination. This one is my to turn. Okay, we put a block here, and mg is acting downward. Normal reaction is this one. This angle is theta. So this angle is r cos theta. This angle is r sin theta. Now as it slips down, so frictional force acting in which direction? Upward? Yes or no? Yes or no? Everyone, yes or
Yes,
no?
sir.
Yes, sir. Dekho, slips down, the frictional force acting upward. Okay, so as the frictional force acting upward, so This angle is theta. So what we can say, mu r cos theta cos theta, and this one is mu r sin theta. So what we can write, the r cos theta plus mu r sin theta is mg, equation number 1. Or you can say this like r cos theta plus mu sin theta is mg. Now see, this is the center. As this is the center, this is your one force, this one is your one force, and they are opposite direction. So what happened? In between these two forces, the resultant force is acting towards the center. That means obviously this force is greater than this one. That then and only then the resultant force is acting towards the center. So we can say obviously r sin theta is equal to theta. That's why the net force is acting towards the center. So what we write, r sin theta minus mu r cos theta, means higher force minus lower force. The resultant is acting towards the center. mv square by r. Here you can write minimum. So r sin theta minus mu cos theta, that is m v minimum square by r, equation number 2. Now dividing equation 2 by equation 1, we can write r sin theta minus mu cos theta by r cos theta plus mu sin theta equals to m v minimum square by r by mg, that is v minimum square by rg. This r cancel, this r cancel. So what happened? V minimum square is rg sin theta minus mu cos theta by cos theta. ये नेटवर्क का प्रॉब्लम है. Okay, r cos theta minus mu cos theta by cos theta plus mu sin theta. So what do you mean by v minimum? V minimum is root under rg sin theta minus mu cos theta by cos theta plus mu sin theta, which is root under rg sin theta by cos theta is tan theta minus mu 1 plus mu tan theta. Yes. Everyone, yes or no?
Yes, sir. Yes, sir.
So that is the minimum and maximum condition. That means whenever you take a circular turn with that banking, if you have a friction also, so obviously you must maintain your car more than the minimum and less than the maximum. If you maintain in between minimum and maximum, then you safely able to take the car turn. Otherwise, what happened? You can either slides down or you can skids up. Okay. So on the basis of that, a lovely question is there in HC Verma. I'm going to give you this question. You try and then I'm sure you. The question is that question is a turn of radius 20 meter is banked for a vehicle. A turn of radius 20 meter is banked for a vehicle going at a speed of 36 kilometer. Going at a speed of 36 kilometer per hour. If the coefficient of static friction, between the road and the tire is 0.4, if the coefficient of static friction between road and the tire is 0.4, what are the possible speed of the vehicle? What are the possible speed of the vehicle so that it neither slips down nor skids up? It neither slips down. Slips down money, you have to find out V minimum, and nor skids up money V maximum. Yes or no? Understand everyone? First of all, a turn of radius 20 meter is banked for a vehicle going at a speed of 36 kilometer per hour. So I can say this 36 kilometer, I can make it 36 into 5 by 18, that is 10 meter per second. Now we know V equals to RG tan theta, that means 10, that is 20 into 10 into tan theta. So if we're squaring both sides, 100, 200, tan theta 100 by 200, that is 1 by 2, that is 0.5. So the first thing is that you get the angle from here, the main thing. Now mu is given V minimum. What about the V minimum? V minimum is that we can use directly R20 G10 tan V minimum is tan theta. Tan is how much? Tan is how much? 0.5 minus mu is how much? 0.4 by 1 plus 0.5, 0.4. So what happened? 200, 0.1 by 1 plus 0.2, that is 200, 1 by 12, that is 106.53. So the answer is 50 by 3 meter per second. Yes, everyone? Everyone, yes? Now the second one. Now the second one, Vmax. Second one is Vmax. Vmax, second one. So for Vmax, Vmax. So what is the formula? RG 20 into 10. Now it will be plus 10 plus 0.4 by 1 minus mu, that is 0.4 into tan theta, that is 0.5. So what you have? 200, 200.9 by 1 minus 0.2, that is 200.9 by 0.8, that is 209 by 8. So I can say 100, I can say 4, that is 10 into 3 by 2, that is 15 meter per second. Yes or no? Everyone, yes or no? Everyone, yes?
Yes, sir.
Yes, sir.
Okay. So after that, next question. Next question. Next question is that. Achha, now I'm giving one more question. A particle describes a horizontal circle. A particle describes a horizontal circle on a smooth inner surface. A particle describes a horizontal circle on a smooth inner surface of a conical funnel as shown in the figure, if the height of the plane of the circle above the vertex is 10 centimeter, find the speed of the particle. Yes. So first of all, a conical surface is given. This is the conical. किसका क्या हुआ है? मनीष, Ganesh. So this is the flux, okay, conical funnel, and a particle is moving in this way. Okay, the height from the vortex is how much? 10 centimeter. I again read the question. A particle describe a horizontal circle on the smooth inner surface of a conical surface. See, smooth or inner surface. That means my mu is 0. That means no friction. That means no friction. Okay. Here I just want to say you one more thing which is very, very important, especially in this maximum. Sometime what happens? Examiner also asks you, what is the optimum speed? Optimum speed. So what do you mean by optimum speed? That means no friction. That means the previous one, banking of road only. Optimum speed matlab without friction. So if you put V0, mu 0, obviously here you directly get the value Rg tan theta. Yes or no? For this one, clear everyone? Sometime they can ask you also what is the optimum speed. So students are confused. Ye kya hai? Ye to kabhi suna nahi hai. That means without friction banking of road. That is called optimum speed. Now in this question, the smooth inner surface of a conical funnel as shown in the figure, if the height of the plane of the circle above the vertex is 10 centimeter, I show it. Find the speed of the particle. Mane, you have to find out the speed of the particle. What is the minimum speed of the particle, or what is the speed of the particle? Option A, 1 meter per second. Option B, 2 meter per second. Net बहुत slow है. Option C, 3 meter per second. Option D, 4 meter per second. So try this question. Okay, I'm again giving you. So what we can say, what we can do. This is the normal reaction. Acha, this angle is given theta. Sorry, forget to give this. This angle is also theta. This angle is 90 minus theta. This angle is theta. So along the base is r cos theta. This is r sin theta. So what happened? First of all, r cos theta balance mg and r sin theta balance mv square by r. Let r is the radius of the track. Let it be equation number 1. Let it be equation number 2. Now, by dividing equation 2 and 1, r sin theta by r cos theta, that is md square by r by mg, that is v square by rg, r cancel. V square equals to rg tan theta, v equals to root under rg tan theta. Clear everyone? Now see here, what happened, let height is given h. Okay, if this angle is theta, what do you mean by tan theta? Height by radius. So if we put this rg, height by radius cancel, that is g into r. So G is what? 10, R is what? 0.1. So overall is how much? 1. That is 1 meter per second. So the answer is 1 meter per second. Clear, everyone? Next heading is, everyone, is it okay?
Yes, sir.
Hello. Next heading is bending of cyclist. Next heading is bending. अच्छा আমি তোদেরকে কিন্তু এটা নোট দিয়ে দিয়েছি হ্যাঁ bending of cyclist. Bending of cyclist. So bending of cyclist में what happened कि this is the circular track. Okay, this is the radius of the circular track, and here the cyclist bend with some angle to get the extra advantage. This is suppose handle of the cycle and this is the bell. Normal reaction is mg is acting downward. So what happened when you take a turn? If you take a right side turn, so you bend towards the right. If you take a left side turn, you bend towards the left. So that is called bending of cyclist. So on that basis, if we say this is the bending with respect to the vertical, let the theta, and this is the horizontal. So I can write this is r cos theta, and towards the center is my r sin theta. So what I can write? I can write r cos theta balance mg, and r sin theta is acting towards the center, mv square by r. R is the radius of the track, dividing 2 by 1 r sin theta by r cos theta mv square by r by mg, that is v square by rg. Here you have tan theta, so v square is rg tan theta. V equals to root under rg tan theta. Yes, everyone? Everyone, is it okay?
Yes, sir.
नेटवर्क इतना, सोचो रिलायंस 5G लिया हुआ है फिर भी ये हालत है नेटवर्क का. आफ्टर दैट द नेक्स्ट टॉपिक इज डेथ वेल. तुम लोग सुना ही होगा मौत का कुआं, सुना है ना? So that is called the death well. Death well. Death well. कोई प्लूटो or rotor. So what happened death well, or what happened in death well of rotor? A whale you have, let the radius of the whale is capital R, and you try to move in this way. So mg is acting downward. So let mu is the coefficient of friction. Mu is the coefficient of friction between tire of bike or car, anything, and death well, wall of the death well. So obviously your frictional force is acting upward. So how you generate that normal reaction? By using the centripetal force. So here the centripetal force is the normal reaction, yes or no? Yes or no?
Yes, sir.
So that means here the frictional force is greater than weight, then and only then it will be possible. Means if the weight is greater than frictional force, so it will be moving downward. But if the frictional force is greater than weight, that friction can hold the bike with the biker. So I can say key frictional force, that means mu r greater than equals to weight. So mu Fc greater than equals to mg. So Fc greater than equals to mg by mu. Okay, so what do you mean by Fc? mv square by r. So cancel. So v square greater than equals to rg by mu. V equals to root under greater than equals to rg by mu. Now see what happened. Now see exactly what happened. V is greater than equals to mu rg. So here the speed is minimum, means if you not maintain that minimum speed, you are not survive, means you are moving downward. So at least you have to maintain the minimum speed. If you move more than the minimum speed, it's okay, no problem, but you at least maintain a minimum speed. So that's why here we equalize during the minimum speed, that is rg by mu. Okay, everyone understand? So that is your rg
Yes.
by minimum speed. See, one question is there related to that. Key. One question is there related to that. A depth well of radius, a depth well of radius 100 meter, a depth well of radius 100 meter. Coefficient of friction between the tire of the motorbike and the wall of the depth well is 0.4. The mass of the bike and rider, the mass of the bike to 200 kg and the mass of the rider 70 kg. The total mass is 200 plus 70, that is 270 kg. Find the minimum speed required by the motorbike to move safely to the depth well. So first of all, as you see, mass cancel each other. As you see from the previous derivation, see, I can cancel this mass. So whatever be the mass, it doesn't depend. Even whatever be the mass means you can ride a bike or you can ride a four-wheeler, doesn't matter. तुम लोग देखा ही होगा वो मूवी भारत, जिसमें बाइक और फोर व्हीलर दोनों लेके घूमता था मौत का कुआं में. देखा है भारत सिनेमा? किसी ने देखा था वो सिनेमा सलमान खान का?
Yes, sir.
Sir.
बाइक और फोर व्हीलर दोनों का ही दिखाया है एक्शन. So you can use bike, four wheeler, anything, say, doesn't matter, but you must maintain a minimum speed. And what is your minimum speed? Your minimum speed is root under rg by mu. That is r is 100, g is 10, mu is 0.4. So how much you have? 100, 10, 10 by 4, that is 255. So कितना होगा? 2500, that is 50 meter per second. Yes or no? Everyone got it?
Yes, sir.
Achha.
Yes, sir.
After that, the next one more is there. That is called from the centripetal force. Next class में थोड़ा बहुत centrifugal force बताएगा. And then we move on to the work power energy. And then हम लोग जो है vertical circle पढ़ेगा. Although vertical circle is also the part of circular motion, but in vertical circle what happened? Against gravity, माने you need the conservation of energy. For conservation of energy तुम्हें work power energy पहले पढ़ना पड़ेगा. So What is the basic difference between horizontal circle and vertical circle? Vertical circle is moving like this. Mane from the bottom, it will move like this top position against gravity and then coming back. And in horizontal circle, it will be moving in the same height like this. So that is the basic difference between horizontal and vertical. Vertical circle में तुम्हें क्या चाहिए? Conservation of energy चाहिए. But horizontal circle में as it is moving in the same height, so you don't need any conservation of energy. तो ये circular part में है. Horizontal circle. Horizontal pendulum, sorry. One is the vertical pendulum and the other is the horizontal pendulum. So what happened in horizontal pendulum? A string is fixed with some length and the string is moving in that way in a circular track. L is the length, R is the radius. Let this angle is theta. So now, obviously, as you have a mass, so you have a tension T, mg is acting downward. This one is also theta. So either you have T cos theta, either you have T sin theta. Now, basically what happened, your upward force, T cos theta, balance mg, and T sin theta is equal to towards the center, mv square by r. Equation number 1, equation number 2 again. So dividing equation 2 by 1, T sin theta by T cos theta, mv square by r by mg. Just 1 minute. Dividing equation 2 by 1, tan theta, cancel, v square by rg. So v is equals to root under rg tan theta. Yes or no?
Yes, sir.
Yes, sir.
Now, if the v is rg tan theta, if v is rg tan theta, so see, इसमें question देता है time taken to complete one circle, time period represented by the symbol t, that is the time taken to complete t, not complete. Time taken to complete one circular motion. So what we can say, time is circumference 2 pi r by speed. So 2 pi r by speed is rg tan theta. You can say 2 pi. देखो r को रूट अंडर के अंदर ले गया, स्क्वायर एक आर कट गया. So r by g tan theta. Yes, everyone. Is it clear? Now see here a very important thing. See here, if this length is L, along the base is L cos theta and perpendicular with the base, that means this one is L sin theta. Now radius is L sin theta and perpendicular is L cos theta. So what we can say here, that is the height. So if we use this one, so that means I can write 2 pi in place of r, I can write this L sin theta. And here we can write G sin theta by cos theta. So sin theta cancel. So we have 2 pi L cos theta by G. 2 pi L cos theta is how much? Height. 2 pi height by G. Yes, everyone. And on the basis of that, I just want to देखो एक क्वेश्चन है, ऑलमोस्ट सिमिलर क्वेश्चन. लेट्स सी द क्वेश्चन. Question is an electric bulb suspended from the roof of a railway train by a flexible wire shift through an angle 30 degree. So angle is given 30 degree. Okay. When the train goes horizontally round with a curved path of radius 200 meters. Find the speed of the train. G जो है बोला है 10 meters per second. You can take. So we know speed is equals to rg tan theta. Yes or no? Just now we see इन्हें देखो क्या है, ऐसे सर्कुलर टर्न ले रहा है ट्रेन, और ट्रेन के अंदर में क्या है, यह है जो कि थीटा डिग्री बना रहा है. So you have to find out this v. I can easily say that my r is 200, g is 10 and tan 30 degree. What do you mean by tan 30 degree? 2000 by आबार चले गए. ये नेटवर्क का इतना झमेला है ना, इतना खराब नेटवर्क है. So r is how much? R is 200. G is how much? G is 10. And tan, how much? Tan 30 degree. So what we can write? 2000 by root 3. Yes or no? And the value is almost 34 meters per second. Okay, everyone? Is it okay?
Yes, sir.
So that's it. Centrifugal force तुम्हारा बचा रहा. Centrifugal force को